everyone. So I'm Shruti Singhal from Think Questioned. So in last session, we have started with what is testing and what is the difference between manual and automation testing. So continuing with that, in today's session, we're going to understand the different types of testing. So let us discuss the agenda of this particular session. In this session, we are also going to understand the different types of testing, the 7 principles of testing, the difference between error, bug, and defect. What is the difference between verification and validations? Then we are going to discuss about the levels of testing and then testing on the basis of knowledge. We are also going to understand 2 black box testing strategies, that is equivalence partitioning and boundary value analysis, and the difference between them. We are also going to understand smoke and sanity testing, regression testing, and lastly, user acceptance testing. So here in this session, we will emphasize mainly on the different types of functional testing. So let us start with it. So let us first of all understand the different types of testings available. So if I broadly classify, the 2 types of testings include manual testing and automation testing. And both the testing have their own usage as discussed before. Now, when it comes to manual testing, on the basis of knowledge, it can be categorized into white box, black box, and gray box. And further, black box can be classified into functional and non-functional testing. Further, you can see that functional testing can be an integration testing, a unit testing, or a system testing. And similarly, white box testing can be done at unit testing, integration testing, and system testing. And when it comes to integration testing, there are 2 types, incremental and non-incremental. And then we have 2 approaches, top-down and bottom-up. And when it comes to non-functional testing, we have performance testing, usability testing, and compatibility testing. And under performance testing, we have load testing, stress testing, scalability testing, and stability testing. We are going to cover all these testing in details one by one. But before starting with that, let us first understand the principles of testing. So these guys, this is also called as the 7 principles of testing. So there are total 7 principles of testing which you have to follow when you are following the testing procedure. And this is directly from ISTQB Foundation. So let us understand the very first principle. So the first principle says that testing shows the presence of defects, not their absence. So we have discussed this thing before also. Whenever we are performing testing, our main agenda is to find the defect, to discover the new defects in our software. It's not proving that there is no error in our software. So testing can show that defects are present, but it cannot prove that there is no defect. That is the meaning of this statement. So basically, we reduce the probability of any kind of undiscovered defects which might be remaining in the software. So also we can also say that testing is not proof of correctness. There might be some more undiscovered defects that are left. If we have done with the testing, that doesn't mean that our software will be 100% bug free. The second principle says that exhaustive testing is impossible. Now, what is the meaning of this? This means that whenever we are performing some testing, we are writing certain test case. So to write the all combination of inputs and precondition is not at all feasible. We have to only write the trivial test cases. So rather than attempting to test exhaustively or with the risk analysis or with the techniques, the priorities should be given to focus on test efforts. So that is the meaning of this particular principle. Let us move to the next principle. It says early testing saves times and money. So we all know the difference between waterfall and agile model. In agile model, we were doing early testing starting from the very first phase of our software development lifecycle. So whenever we are doing early testing, we are able to detect an error at an early phase, and eliminating that error which is detected at the early stage is cheaper as compared to detecting the same error later in the stage. The next principle says that defects cluster together. So what does this mean? So this basically means when we have small number of modules, they usually contain most of the defects discovered during the pre-release of testing, and they are responsible for most of the operational failures. So when we have predicted some defect clusters, then the actual observed defects clusters in the test or operation, they are more important to risk analysis. So we should combine the defects which are of same cause. That is the entire meaning of the statement. The next principle says that beware of the pesticide paradox. This means if we are repeating the same test over and over again, eventually they are not going to give you any kind of new defects, right? So to detect any kind of new defects, we should not repeat the same test again and again, right? Because they will not lead to any kind of new change. So you should be writing some new test, right, for that thing. So tests are no longer effective at finding defects. So just like, so why we are saying pesticide paradox? So it is similar, just as pesticides are no longer effective. So they are not effective anymore to kill the insects after some times, right? For example, if you're using the same pesticide again and again to kill the insects, after a certain period of time, that will not going to impact on the insect. The similar way, if you're doing the repeated test cases, that is not going to find any kind of new defects. So that is the meaning of this particular principle. Then the next principle says that testing is context dependent. So testing is context dependent means, so if you are doing testing, so it will differ according to the context. So there might be softwares which are critical, for example, where there is more risk analysis like healthcare or banking application, or there might be softwares like e-commerce application. So in both the cases, the testing will be different. In some of the project, you might be using agile methodology. Some of the projects you might be using waterfall. So it might differ from application to application. The last principle says that absence of error is a fallacy. So this is very similar to the very first principle that we have just discovered. Okay. So some of the organization expects that testers can run all possible test cases and they can find all the possible defects. But as stated in principle 1 and 2, this is impossible, right? This is a fallacy. This is a mistaken belief to expect that just by finding and fixing a large number of defects will ensure that my system will always be in the success and it will not fail, right? So we have to thoroughly test all the requirements and we have to fix all the defects found, but it could still produce a new defect or it could still find something which is not fulfilling user expectation. So that is the principles of testing, and we should know all these 7 principles. Now guys, let us move towards a very, very important question, that what is the difference between error, defect, and failure? So sometimes we get confused between these 3 terms. So first of all, this is nothing but a life cycle, okay? A error result in a defect and a defect result in a failure. But what is the difference? How you are going to give a difference between the 3? So let us understand with the help of an example. For example, there is a developer or a programmer. He makes certain error in the logic. So that is an error. So this error will introduce certain kind of bug in my software. And when the faulty software is executed under certain conditions, it will lead to certain kind of failure. So whenever we say what is a defect is something that is introduced by a programmer inside the code, the bugs, right? That is introduced by the programmer inside the code. Basically, what is happening over there is we are deviating from our actual and expected result, right? So whenever there is deviation between actual and expected result, that is going to give us a defect. So that is the reason for defect. So maybe we are giving wrong input because of which we are getting the defects, or there is some error in the logic code because of which we are getting a defect. Now let us understand what is a bug. So sometimes we get confused between these 2 terms, defect and bug. So bug, we can say it is a more informal name of a defect. So these are nothing but a fault in a system or any kind of application that is going to impact the software functionality and performance. And these are generally fine found by the testers during unit testing, right? And then comes what is a failure. So when this defect reaches the customer, the end customer, it becomes a failure, because once the product is completed and it is delivered to the customer, and then if the customer is finding any issue in the product, that will return to result into the failure of the product. So that is why we say when an end user is going to find an issue in the product, it will result into failure. This could be because of environmental condition also, some human errors also, or it could be because of the way they are using the system. Maybe they are not using the system in a correct way. So guys, this is the difference between these three terms, that is error, bug and defect. I hope it is clear to everyone. Now, let us move towards a very, very important term. We have already discussed this term when we were discussing what is software testing. So in this particular slide, we're going to understand what is the difference between verification and validation. These are two terms, but sometimes we do get confused with these terms. So when I say verification, can be also said as static testing. And when I talk about validation, this can also be termed as dynamic testing. So if it is asked that what is the difference between static testing and dynamic testing, you can give the same answer. Because static testing is nothing but verification and dynamic testing is nothing but validation. So verification basically says, are we building any product in a right manner? So the product that we are going to build, are we building in a right manner? We basically evaluate the product to find whether they are meeting the customer requirement or not. Here we are not going to execute any kind of code. Okay. So how do we do it? It is done with the help of reviews, with the help of meetings, like we do sprint review, right? And we do inspections whether we are meeting the customer requirements or not. So it is done by the quality assurance team. Okay. So we do not execute any kind of code in this particular process. So it is done while developing the code. Okay. Whereas validation is done after you have developed the code. So that is why we say, are we building the right product? Here we check with whether we are building the right system or the product. So here we are going to evaluate our software at the end of the development, as I just said, in order to determine whether all the customer expectations are met. So here we are actually performing the testings, which involves black box testing, white box testing, and gray box testing. So here we are also going to execute the code, right? And here the testing is done by the testing team. So that is the verification and validation. So verification is happening within the process. And that is why we have every sprint and then we check whether the requirements is met. We have the meetings with the stakeholders to say that whether everything is done according to your choice or not. And then we again do any kind of changes. But validation is done at the end once the whole software is there, once the development process is completed. Right? Okay. So now let us move ahead with the levels of testing. So guys, again, levels of testing is not types of testing. It is going to define how we need to proceed when the testing starts. So the level of testing consists of 4 levels. The first one is unit testing, then is integration testing, then is system testing, and the fourth one is acceptance testing. So unit testing basically means testing an individual component. Integration testing means when we combine some modules together and then we test them. System testing basically means testing the entire system, and acceptance testing basically means when the end user or the stakeholders are actually testing the final system. So now let us discuss about this testing, the levels of testing a little more. So when I talk about unit testing, what is happening? We are here testing every smallest unit in the software, right? Which is known as a unit. Here we are actually testing every small bits of the software. Whereas in integration testing, what we are doing is, for example, we have one module of login and then we have one module of payment, or we have one module of order. So we are integrating the components and then we are checking whether they are able to perform. So again, if I talk about integration testing, it has a lot of approaches like top-down approach and bottom-up approach. Then we have system testing, in which we are testing the entire system. The entire software is working according to the customer requirement or not. And in user acceptance testing, the end user will check the delivered software and they will give their own feedback, whether the delivered product is meeting a requirement or not. Right? So these are the types of testings, or we can say levels of testing. Next, guys, integration testing is a very, very important testing, because in unit testing, we are just checking the single modules. For example, login module, for example, payment module, search module. So we are just checking the unit, same smallest module, right? Whereas in integration testing, what we are doing is we are combining the module. For example, we will test after login whether we are able to place the order or not, and then whether we are able to do the payment. So we are combining different modules together to search for a certain functionality. So when it comes to integration testing, there are a lot of types which comes under it, like big bang approach, right? Then we have incremental approach. And inside the incremental approach, we have bottom up, top down, and sandwich approach. So let us a little bit discuss about what is this. So when I talk about big bang integration testing, here we wait for the components to get ready and to get integrated, right? And testing is performed over those modules. So this is done generally during the waterfall model, which is basically going to work sequentially. It is not used generally in agile model, and that is why you might not have even heard about this name much, right? Because here we are doing in a sequential manner. Whereas in incremental integration testing, we basically begin as soon as two or more components can be integrated. So that begins once the one phase is completed, and then we start with it. So we do not wait for any kind of additional components to be made available. So the scope of this particular testing is minimal. So this is to basically ensure that defect can be easily isolated to these components, right? So here we are able to catch the defects in the early cycle, and thereby we are reducing the cost. Now, incremental testing can also be classified again, as you have just seen. So the very first one is bottom-up integration. So in bottom-up, basically integration means that we are starting from the lower level, and then we are testing them with the higher level modules. Whereas in top-down, it is just the reverse. We are testing the models at top level, and then we are integrating them with the lower level. So that is basically top down and bottom up. And when sandwich, it is a hybrid approach where we are doing parallelly from top down and bottom up both. So that is called as sandwich integration testing. Now, sometimes a question that is asked to many people is that when it comes to integration testing, sometimes it might be possible that when you are doing bottom up or top down approach, either the higher module is not ready or the lower module is not ready. So basically, you want to perform component testing, but you want to do it in an integration testing manner, right? So how we can do it if they are not ready to be deployed, or if they are not ready, right? So in that situation comes the picture of stubs and driver. So this question might not be asked directly, but this is the way they ask it. So for example, we have a component over with us that is a login page and the admin page, right? We have two components, if you can see on the screen. So in the login page is module A and the admin page is module B, right? So when we talk about stubs, right, and we have driver, so we have two approaches. So what is the stub and driver? Let us first understand, then we will discuss this particular thing. So when we talk about software testing, stubs and drivers are components which is used to facilitate testing of individual modules, right? So when their dependencies is not yet ready, right? So they help us to create a control testing environment by simulating the behavior of the missing part, right? So these are both dummy modules, stubs and drivers. So what is a stub? Stubs are dummy module that basically simulate the behavior of modules or functions which is not yet implemented. So stubs हम किस में use करते हैं? Stubs are basically used in top-down integration testing approach. So what is this top-down integration testing approach? Here, the higher level of modules are tested first. And what is the stub? Stub are the lower level modules. So as you can see in this example, higher level module over here is what? Stub is what? As I just said. Yes, stub is my lower level module, right? Stub is what? It is used in top-down integration testing. So we are testing what? Higher level module. So stub will represent my lower level module. So what is the lower level module over here? Admin page. So first we will test the login, and then we will see now whether admin is able to do it or not, right? So admin will also do certain kind of login. So herein we are testing the login page, but still this admin page is not ready. So we basically create a dummy code over there. Okay. We write a dummy code just to see whether we are able to call that particular method or not. So they are very predefined response or behavior. They will just respond to that particular call, right? As if whether we are able to call that system or not. For example, if a module required data from a database, but our database is not ready yet, so stub basically can simulate data responses. They can just give you some predefined data. For example, you are fetching some user ID and password, right? And the database is not ready. So you will write down some ID and password and it will give you some predefined data. That is the logic behind the stub. Now comes what is a driver. So drivers is a dummy module which is basically used in bottom-up integration. So they will simulate the higher level modules, right? They will also simulate the behavior of calling modules. So they will simulate the higher level modules. So over here, lower level modules are ready, but higher level are not made yet. So they will simulate their working. So here driver will provide input to the module under test. They provide some they mimic the basically interaction of a real calling module, right? For example, there is some low level utility functions that need to be tested. So driver can be created basically to call this function with some specified input and verify the output, right? So they are just temporary substitute which enables a tester to isolate and test a specific component without waiting for the entire system to get fully developed. If you can just see over here, suppose our login page is not ready and we want to check whether admin particular module is getting open or not. So we will just have some predefined user ID and password and the login page will be able to call the admin page, right? So this is how basically this can be achieved. So this is a very important question that is asked in the interviews. Now guys, let us move ahead. So now we are going to move about the different types of testing. So the very first type of testing that we're going to discuss is on the basis of knowledge. So when I talk about testing on the basis of knowledge, then we can broadly classify these testing as black box testing, white box testing, and gray box testing. So what is this? So black box testing is a testing where we just verify the functionality. We do not consider the internal code, how the internal code is going to happen, what is the logic written inside. We are not concerned about it. So here the tester will not have any knowledge about the internal structure, design, or any kind of implementation. And this type of testing is done basically by the testers, right? These are done by the QA engineers or testers. So what is happening? What is going to happen in black box testing? Let us understand that. So when we talk about black box testing, for example, we have a pizza delivery app like Domino's or something. Okay. So what are we going to check? That whether we are going to place an order, right? Then after the order, whether we are able to pay for that order, and after that, whether it is getting delivered to us. So we are just checking the functionality. We are not aware how the internal process is going on. So that is called as black box testing. Whereas in white box testing, we examine the source code. So this is basically done by the developers. Here, we should have the complete knowledge of the internal structure. Here, we actually check the code. Suppose there is an if-else statement. So we will see whether the if portion of that statement and else portion of the statement is working fine. So we should have a complete knowledge of the code. And that is why it is done by the developers, right? For example, if suppose in this pizza delivery app, you have some discount code, okay? Different type of discount code, which is working on the strategy of if else. And you just want to see whether the discount calculation is happening fine. Then you need to check the code behind that. So that is called as white box testing. And the last testing that we have is gray box testing. So gray box testing is basically the partial knowledge of system internal working, right? Here, we should have little bit knowledge about how the system is behaving. Like, for example, how the things are going in the database, which database is used, and how it is getting in the front end. All these basic things we should be having knowledge about. So here we are not having the complete knowledge about the internal structure or code, but yes, we have the partial knowledge about the working of the system, right? So this is done by the tester, who has little bit code knowledge. For example, if I just talk about the order history in the pizza app, okay? So if I want to reorder the same thing, so how can we check? Suppose the order history is not properly visible. So that is a part of gray box testing. We will just check that whenever we are placing an order, is it going to save in the database or not? Is it saving in the database? And then are we able to fetch those particular order from the database to add in the order history? So here we are not having the internal knowledge properly, but we are not just checking the functionalities. We are having little bit knowledge of internal workings also. So such kind of testings comes under gray box testing. So these are the various testing based upon the knowledge of the tester. Now guys, let us move ahead with the two important black box testing strategy, which is equivalence partitioning and boundary value analysis. So there are more other strategies than this, like error guessing decision tables, but these two strategies are very important. So we are going to discuss about these two. So the very first strategy that we have is equivalence partitioning. So let us first understand it through the slide, then I'm going to go into deeper understanding of this. So here you can see equivalence partitioning. We have given one example that an application allows the user to enter the password of length 8 to 12 numbers. And that means we can have minimum 8 numbers and maximum 12 numbers. So what will equivalence partitioning will do is it will create three classes. Two that is below the range and above the range, and one within the range. So it has created two invalid classes, that is less than 8 and greater than 12, and one valid, that is between 8 to 12. So that is called as equivalence partitioning. But when we talk about boundary value analysis, here we are going to create the test cases on the basis of boundary. For example, a software allows people of age group 20 to 50 years. So what is the minimum value over here? 20. So that is why we are able to check. We will be checking the test cases on 19, 20, and 21. And what is the maximum value allowed? That is 50. So we are going to check again, the test cases will be made on 49, 50, and 51. So just at the same point, one below and one above. That is how basically we are making the test cases over here. Now let us understand why we are doing all these things. So let us understand first of all equivalence partitioning, and then we are going to understand about boundary value analysis. So these, as I told you, are two strategies. So equivalence partitioning, that is a black box testing technique, where we have range of input values and we divide them into some classes. And the tester can test at any random input from those classes and check whether we are getting the correct response or not, right? Whereas in boundary value analysis, what we are doing is we are checking the behavior of application at the boundaries, right? So whatever boundary is there, we are checking just one plus and one below. So we have to verify that it is working perfectly on those boundary level areas. Now, when I talk about the differences between the two, then boundary value analysis is basically going to focus to test the things at boundaries or edges, whereas equivalence partitioning is going to divide the input data into some groups. And all the data in that group has to behave in a similar way, right? Then what is the purpose? So if I talk about boundary value analysis, here we have to identify the error that occur at the boundary values. And wherever in equivalence partitioning, we are reducing the total number of test cases by grouping them into some classes, right? That is why we are just reducing the number of test cases. And I have given an example for both of them clearly. So you can see some more examples written over here. So in boundary value analysis, we focus on testing the edge values, the values just inside and outside it. And here in equivalence partitioning, we select one representative value from each classes, right? So again, the coverage, it ensures boundary conditions are tested with precision, right? And it gives us equivalence partitioning actually gives us broad coverage, right? And if I talk about the efficiency, then boundary value analysis is useful for identifying any issues at the edges, because edges are more prone to errors, right? Whereas in equivalence partitioning, we are just reducing the redundant test cases by categorizing them, right? As I said, defect cluster together. That is the thing that we are doing over here. And it may require testing several boundary points for completeness. So complexity of that That is the complexity of boundary value analysis, whereas in equivalence partitioning, it just simply focus on few values, right? So, what is the best use case when we are saying boundary specific errors are suspected? And in that situation, we have to precise our input limit. Whereas when the input is very large, then we have to overlap some of the test cases and we use equivalence partition. So these are two very important types of black box testing, and the difference between them is also asked a lot in the interviews. Okay. So this is all about equivalence partitioning and boundary value analysis. Now guys, come into the picture a very, very important testing, that is smoke testing. And now let us discuss the same. So smoke testing is what? So it is a part of functional testing, guys, which is also called as build verification testing. So before understanding the points related to smoke testing, I would like to show you one diagram related to it. So if you can just see in this diagram, I have just shown you certain builds. So what happens is whenever we are building a software, we create various versions or build of that particular software where we say that, yes, this particular software is deliverable at this particular end. So suppose we have created a build number one, then what we are going to do before releasing that software, we actually test that build. So that is a part of smoke testing. We are going to discuss what we actually do in this particular testing. But let us first understand. So if the smoke testing is passed, if this particular test is passed, that means the build is accepted. Otherwise, the build is rejected. And then we create another build and then we perform the same thing again and again. So if the smoke testing is passed, then actually we move on to the next testing areas like functional test, regression test, and system test. So this is a very, very crucial part of a build. So what happens in smoke testing? Now let us discuss. So smoke testing is, guys, it is a quick and shallow check of all the core functionalities of an application. So it is a shallow testing. And here we are basically checking the core functionalities of an application to ensure that the build is stable enough for any kind of deeper testing. So broadly, we actually test the functionalities. So we also call this build verification testing, and it is done after you develop any kind of new build or deployment. So who does it? It is done by the QA team only, and it ensures that there is a stability for any kind of further testing, right? So if that build is not stable, then simple, we are not going to proceed for any other types of testing. Otherwise, we will do other testing like functional verification and all such testing. So a set of very high level test cases are prepared in this, which are meant to be executed before any kind of proper testing. And these tests could be manual test or automated test. So we can have a predefined or scripted test also. So if the test fails, the build is said that it is unstable and it cannot be tested anymore until you create a certain new build which is stable enough for further testing. So let us understand with the help of example. For example, you have an e-commerce application after a new build. What you are going to check? You're going to check, can the users log in that application? Can we search for a product? Can we add those items in our cart? Can we place an order? Is payment option working properly? Are the order delivered? So this is broad classification of all the testing area. So that is why we say it is broader and shallow. So if all the above are working, we say that the build passes the smoke test. So that is why this actually tells us the overall functionality is working fine. So this is basically done so that you are not wasting so much of time for further testing. If you here only know that the build is not stable, then you're not going to waste your time in regression testing, in further functional testing or sanity testing and all these things. So here we can also use continuous integration and continuous development pipelines. These are a part of automation. So what is the benefit of doing smoke testing, right? So here we are able to catch the bugs early and thereby saving the time and effort in further testing. And also we are going to improve the quality, right? So for example, if a QA is performing smoke testing, so if it is going to fail, then it is going to say that you have to build a new build for this particular thing. So that is a part of smoke testing. So I hope smoke testing is clear to everyone, and this is the diagram as I have just shown. Now with smoke testing, there comes one more testing which sometimes the students get confused. So that is sanity testing. Let us understand what is sanity testing. So sanity testing is basically a subset of regression testing, right? And it is generally done after the smoke testing. After we say that the build is stable, then the further testing on the stable build that we perform is sanity testing. If smoke testing is going to fail, you will not go to the sanity testing. So what is sanity testing? Sanity testing is a narrow and deep testing, right? We are not going to check all the core functionalities over here. We are just going to check the new functionality that is being added in the software, but we are going to deeply test it to verify if there is any bug or anything that needs to be fixed in the new feature without breaking any kind of existing functionality, right? So it checks the correctness of the recent changes that we have done, right? And it is also done after there is any bug fix or if there is any minor update in the application. For example, you have added a new version of payment that is pay through UPI, right? And it is generally not scripted. So this is a manual testing. This is a more of part of a manual testing because it is exploratory. And again, it is done by the tester. So let us understand. So it is basically, as I have told you, it is done after the smoke testing. So for example, if I have a scenario where a developer fixes a bug that the search filter wasn't working properly. There was a search box, it was working properly, but the filter in that was not working properly, right? So we verify that search filter now return the result. So all the related parts like clearing of filter, sorting by price, we have to ensure that all these things are also working properly. Not any other thing we are going to check over here. So you will not test the entire site. You will just test the thing which is going to be impacted by the fix. So that is why it is very quick, right? And it is focused, right? And it is narrow and deep. So it does not follow the test cases strictly. It is generally ad hoc also, right? So it ensures the application does not have any broken, it is not broken after doing any kind of smaller updates, right? Suppose now you are able to apply the filter, but clear filter option is not working, or we are not able to sort. So that is the approach that is done in the sanity testing, and that is why it is ad hoc and exploratory testing. It cannot be scripted, right? So this is a part of sanity testing. Now, guys, there is one more testing that comes into the picture. As I said, sanity testing is a part of regression testing. So now comes in the mind, what is this regression testing? Okay. So regression testing is also a type of software testing, which is done whenever you are having some new code changes. So whenever you are incorporating any new code changes, we need to check whether there is some existing functionality which is there is not being broken or not. We do not have any broken existing functionality. So every time, whenever we are having a new feature is added, whenever we are having any new feature which is being added or any bug is being fixed, we do regression testing to basically maintain the overall stability of an application. So what do we do here? Whatever test cases we have already made, we rerun those previously executed test cases to make sure all the existing features are still working properly. That when we have done any new code changes, those particular things are not broken. So when it is done, whenever we are doing any bug fixing, any new feature is added, any code optimization is done, or whenever there is new sprint or some release that is being going to happen, then we do regression testing to basically catch any kind of side effects that is coming because of the new changes and to ensure the stability of the system after the updates and to obviously maintain the quality of the system. We perform regression testing. So basically it is a testing to ensure that the new code changes have not broken any existing functionality. So that is regression testing, and this is a very, very important testing, right? And as I have discussed, so how we basically do it? We actually select a regression test suite that is the previously passed test case, and we rerun those test cases on the new build, and we compare whether the actual result is matching with the expected result, and if there is any failure, we just simply report them. So again, the regression testing could be of various type, like unit regression, which is done during the unit testing, focusing on specific modules. It could be partial regression. We are just checking the affected modules, or it could be complete regression, where we are checking the multiple modules which are changed, or it could be selective, where we are selecting certain test cases and then we check the traceability of those. So if I talk about regression testing and sanity testing, then regression is going to cover wide areas, whereas sanity is just going to cover the affected functionality, right? For example, let us discuss an example. For example, you have a payment option, but now you have added a lot more payment options in your site. For example, initially it was just by the card, right? Now you have added cash on delivery also, you have added payment to UPI also, and you have added a new feature of adding discounts also. So many new things that you have added. So you need to check that still I'm able to add the product in the cart or not, right? So that could be a part of regression testing. So when I'm doing the complete regression, I'm going to check my login functionality is not broken, my payment option is not broken, my OTP functionality is not broken. All the functionalities are still working. If I forgot my password, everything is working fine. All the previous payment options are working fine. I may be able to place the order. The order is going in the order history or not. So I check all those things again. That is called as regression testing. Now, the question generally which confused ourselves, we know what is smoke testing, we know what is sanity testing. But when it comes to explaining the difference, we should be having clarity about it also. So smoke testing is to determine whether the build is stable or not. And sanity is done after the smoke to basically verify a specific functionality in which we have done the change. So in for smoke testing, we cover all the core functionalities, whereas in sanity, we only cover the specific areas of feature. So if I talk about the depth, then smoke testing is shallow. We don't go deeper in any particular functionality, whereas in sanity, we go deep inside that specific functionality. So smoke testing help us to early detect any kind of major issues, whereas sanity is going to verify that whatever change we are done, it is not going to break any other functionality. So smoke has a broader coverage, whereas sanity has a narrow focus. And it is quick to do smoke testing, and whereas relatively it is very time consuming to do sanity, right? So as I have discussed, it is conducted after a build or release. Smoke testing is done after a build or release, whereas sanity is done during the later stages. And in smoke testing, we are going to build a high level of test case. Whereas in sanity, we have selective test case related to any recent changes we have done. In smoke testing, we focus on identifying severe defects, right? Whereas in sanity, we are detecting regression issues or issues related to the recent changes. So that is why minimal setup is required in smoke and extensive setup is required, because we are detecting some specific changes in sanity, right? So in smoke testing, the build is stable or not, we are just checking this thing. And in sanity, we are checking the specific changes making any kind of impact or not. That is why, if I talk about smoke testing, determines whether to proceed with the further testing or not. That is the decision that we have to make. If the build is stable, we are going to proceed, otherwise not. Whereas in smoke testing, we say whether the changes are acceptable or not, whether they are meeting the expected requirement. So that is the difference between smoke and sanity testing. Now, guys, we are starting with the last level of testing that we have taken into accountability, that is user acceptance testing. As I told you, the first level is unit testing, then integration testing, then system testing, and last one is user acceptance testing. And this is also a very, very important level of testing. We also say it as UAT testing. That means user acceptance testing, which is the last step of software testing, where we actually verify that the software is fulfilling the initial goals which are stated by the user requirements on it. This is the main. So as you can see in the diagram also, the development is done, then we have the QA team, then we have the UAT team, and then it goes into the production. This is how the cycle actually goes through. So during UAT or user acceptance testing, so what happens is the user is going to check that the business behavior and functionalities are working as stated. So here we basically have the real world scenarios we implemented on behalf of end user and verify that the requirements are being fulfilled or not. So it is performed after persistent system and regressions testing, everything has been done. So who does it? So it is basically done so it is completed by the client or the end user to validate that everything is properly communicated and executed. So who's the client? The stakeholders of the system, and end user, they also do it. So who are the user? These are the individuals who are going to use the application, maybe most of the times. So it is important to form a user a part of entire quality strategy within this process. So how it is done? So there are a number of steps for performing this test, and they might vary for every team and from project to project also. So first of all, we include a designing section where the business strategies are required to make public. Then the possibility is to check for identification of any business strategies. Different possibilities of meaningful cases are required to check what the end users can face. And then we have different groups of testing that need to be chosen. So developer choose end user for testing software package or provide free trials sometimes that any user can use it. And after testing, the document section is provided to the document to find any potential bugs that can be encountered. And after the documentation of all these things, then we fix all kind of bugs that are going to be raised, and then we complete this particular type of testing. So this is done in the real world scenario. Now this is also of two types. One is alpha testing and the other one is beta testing. So what is the difference? So again, see, you can see first we do alpha testing and then we do beta testing. So alpha testing is basically done by the internal employees of the organization. They create the real world scenario for themselves in the lab itself. And before launching that particular application, they actually check whether this is working fine. So alpha testing is basically conducted by a team of highly skilled testers at development phase, while beta is done in the real time environment where the actual customers are going to use our system at their own sites. In alpha testing, you need a lab environment or testing environment, whereas in beta, it does not require any lab environment. They're going to test at their own site, right? So alpha testing is done on site, therefore developers as well as business analysis are involved, whereas beta testing, developer and business analysis are not involved in it, right? So furthermore, what is the time of testing, right? So alpha testing is just done before the launch of the product, and beta testing is just done at the time of marketing, right? So what are we checking? What are validations are done? So we check for functionality, internal things, right? And in beta testing, we check for the reliability and security of the application. Then comes to the goals. So when we talk about alpha testing, it ensures that the product quality and design is ready for the beta testing. And in beta testing, we are actually evaluating the customer satisfaction for the full release. So in alpha testing, we might be doing white box and black box both, whereas in beta, we do not have the internal knowledge. So we are just doing black box testing. So what is the duration? So if I talk about alpha testing, it includes multiple test cycle, maybe 1 or 2 weeks, varying for every issue. Whereas in beta testing, there are few types test cycles, depending upon the feedback of the user. So when do we do alpha testing? When developers immediately work on the identified issues or bug, and feedbacks when it is received and it is implemented in the future versions. So as I told you, who performs alpha testing? It is typically done by the internal tester, which is a part of development team or the company. And beta testing is done by the external user. This could be some customers or early adopters or some general public depending upon the product. So that is the difference between alpha testing and beta testing. So that is all about, guys, today's session. So in this session, we actually covered a very important areas like what is testing, what is functional testing, what are the different types of testing. Then we discussed about the difference between verification, validations, and the 7 principles of testing. We also discussed about the levels of testing, which includes unit testing, integration testing, system testing, and user acceptance testing. In integration testing, we focused on top-down and bottom-up approach and the meaning of stubs and drivers. Then we move ahead with the testing based on knowledge, that is white box, black box, and gray box testing. Then we focused on smoke, sanity, and regression testing. And lastly, about user acceptance testing, and most importantly, alpha and beta testing. So that's all about today. Next session, we're going to start with the non-functional testing. Thank you, everyone.